So I'm going to explain to you what El Nino and La Nina is, but in order to understand what El Nino is, you have to understand what normal is. So what is normal in the Pacific Ocean? And including what upwelling is. For this assignment, you should have a couple of colored pencils or markers. Colored pencils would work best, or even highlighters if that's what you want. You will need a warm color like red or orange or pink, and you need a cool color like blue or green, blue's better, to indicate warm and cold water. But first, let's go ahead and talk about what upwelling is. And so I'm going to show this animation here from YouTube on what upwelling is. So we're seeing a visual of the west coasts of the Americas, so Peru or California. And this is what happens off our coast. We have cold water from the bottom that comes up. And the reason why it does this is because the winds will blow south. So it doesn't show it very well in this YouTube video, but the winds blow south. And then because of the Coriolis effect, which is the spin of the earth, it actually diverts the water out away from the coast. And then water from below has to come up to replace that water. And that's basically what upwelling is. Now, upwelling occurs in several places around the world. It occurs on the west coasts of the Americas. It also occurs around the equator too, and it has to do with how winds blow surface water away and how cold water from below will replace that water, and that water from below is full of nutrients. So let's go ahead and we're going to sketch that out ourselves. So we're going to just make a simple drawing, and I would do this at the side of your paper or the back of your paper. So if we're just going to draw here the slope of the ocean, and we'll kind of make that the ocean, and so over here is land, and then we have ocean water here in blue. So again, the wind is blowing south, so wind is blowing south. But the spin of the earth deflects that movement once it gets to the water, so the water flows away from the coast. And this is because the wind and the water get deflected, and we call that the Coriolis effect. And so down here at the bottom of the ocean are nutrients, nitrates, potassium, phosphorus, carbon, anything from dead, decomposing organisms. Why are they at the bottom? Well, because when a fish dies, it's going to sink to the bottom and get decomposed, and its nutrients will be returned, or a whale or anything. Also on land, rainstorms will bring sediments down that have these nutrients, but they will fall all the way to the bottom of the ocean. And so we have a problem in the ocean in that the nutrients needed for photosynthesis, nitrogen, phosphorus, potassium, even things like carbon, are all at the bottom. But remember, producers need these things, but they also need light. And the sun is up here. So the photic zone is here at the top. That's where light can penetrate, the photic zone. So nutrients are at the bottom, light's at the top. And so that's a problem for food webs because you need both for your producers to start your food web. And we call that productivity. How much productivity is how much photosynthesis is going on and how much can be passed to our consumers. So when we have a circumstance where the winds are blowing the water away from the coast, now we have this cold, and cold water holds more oxygen too. So this cold water from below comes up to the top. And so now we have here nutrients and light. and we have a burst of productivity. And so the important part of all this is that because of this, we get high primary productivity. These are terms that the AP test uses frequently in released exams. Why does one section of the planet have more productivity than others? So they use the word productivity, and it also means good fishing. So go ahead and write those things down. So upwelling gives you high primary productivity. So your producers, which are basically your plankton and algae in the ocean, and occasionally seaweed. Seaweed is more close to the coastal areas. So you have some seaweed, but mostly plankton, algae, and other phytoplankton. They get light, they get nutrients, they make a ton of copies for themselves, and it starts the food chain. And that's why upwelling is really important. So off the coast of California, we have normally a lot of productivity. And so here are some things that you need to write down. What is normal? Well, off of our coast is cold water. So go ahead and draw in cold water, because our water off the California coast comes from Alaska, and it's cold. And the water here in South America over by Peru, and the reason why I mentioned Peru is because they're the first people to identify the El Nino, because it happens mainly around December. But I haven't got to that yet. So the Peruvians are excellent fishermen, primarily due to the upwelling along their coast. So it starts to warm up once it gets down, and the currents move the water this way. So the currents move the water down our coast and then out this way. And then they make this big gyre. All right, so it makes this big circle. And then down here, here's the other gyre, which is a big circular current. And so the cold water starts to move this way, but it's along the equator, and it's going to take several months, and as it goes, it's going to start to warm up. And by the time this water gets over here to Asia, it's going to be nice and warm. Or over here to Australia, it's going to be nice and warm. And so we get cold water off of our coast, warm water off the east coast of Asia. Well, the nice warm water, what it does is it evaporates, and it creates a lot of moisture over here by the equator in Asia. I made my rain cloud a little bit too big because it's not this entire area that has rain. Let me erase all that. And it's just some of the area that has rain. So just know that it's equatorial. It's not letting me erase. But, well, it's warm rain. And so we have here warm rain that comes down. And the rain here in equatorial Asia, we call the monsoons. So nice warm water evaporates, creates a lot of rain in equatorial Asia. Okay, so what do we have? Well, off of our coast, we don't have that situation. So for us here, we normally have dry conditions. That's normal for us. But off of our coasts, we also have upwelling. I know I'm drawing over here in the Atlantic, but I'm going to draw some arrows. So upwelling occurs over here off of our coast and down here in Peru and the coast of Chile. Nice, good upwellings. So in an El Nino, so this is normal, and for us, we have an advantage in California because we know what normal means. El Nino is the opposite of normal. So on occasion, what will happen is that, number one, first let me back up. Why does this water go this way? winds. They're called trade winds. And the trade winds here blow the water across the equator. So trade winds. You'll be able to write smaller and neater than I am on this app that I'm using. Okay, so the first thing that happens in an El Nino, number one, trade winds die. And number two, warm water moves back. Back to the eastern Pacific, which is the west coast of the Americas. So going back up to our normal picture, this warm water keeps getting pushed and it kind of makes this big area of warm pool of water that's actually several feet higher than it is on the other side of the Pacific. So over here, the western Pacific has this bulge of warm water because the trade winds keep blowing and blowing and blowing and blowing and blowing and blowing it east. So this big bulge of water now is going to move downwards because gravity, if the trade winds die off, gravity is going to make that bulge of water start to move downward and towards the eastern Pacific, towards the Americas. So again, the trade winds are normally blowing all that water west towards equatorial Asia, and then the water's going to come back. So let's go ahead and talk about this. So now what happens is the trade winds die off and this big bulge of water is going to start moving this way. And then it's going to end up off of the coast of California and off the coast of Peru. And we say that when this warm water appears, we are in an El Nino. So an El Nino is not rainstorms and it's not mudslides, not storms. It's actually the presence of warm water. So the warm water often, most often, it doesn't always work this way, but it often creates a ton of rain. So when we have an El Nino off our coast, we usually end up with a ton of rain. But the warm water is moving away from equatorial Asia and Australia, which actually means they have less warm water, so they don't get the monsoons and they end up with a drought and a lot of fires like in Australia. So for Australia is actually a big predictor. They do a lot of work to predict El Ninos because they know that when an El Nino occurs, they get huge fires and drought. For us, it's the opposite. We get a lot of rain and snow and we fill up our water reservoirs. But one of the biggest issues for the fishing industry is that upwelling stops. Because the winds are blowing in the other direction, and so it's going to stop the upwelling here and here off the coast of Peru. And so it's the fishermen in Peru were the ones that first called it an El Nino. In December is when they started noticing that the fish had gone away because upwelling had stopped. There was no food for the fish. And then some fish don't like that warm water, and so they try and search for colder water. And it occurred in December, which is the Christmas month, and so they named it El Nino after the Christ child. And so upwelling stops, and this is bad for fishing. And in places like Peru, the economy is based on fishing, and so this is really bad for the fishing economy as well. So when you are discussing an El Nino, let's say you have an FRQ about an El Nino, you need to be really clear about the words east and west. So if you say during an El Nino, warm water comes back across the Pacific to North America and South America. you need to say, that's too vague, you won't get a point. What you would say is that warm water comes from Asia eastward across the Pacific Ocean to the west coast of North and South America. So be really clear with your words east and west to really show that you know what you're talking about. And then we have La Nina. So a La Nina, I like to call it an extreme normal. All right, so La Nina often follows an El Nino the next year. So I'm recording this in the year, in January of 2017, and off our coast we have a La Nina because last year we had an El Nino. But our rain patterns haven't exactly followed La Nina because normally in La Nina we have more of a drought. So Southern California is typically a semi-arid, so a semi-dry landscape, but in a La Nina we typically have less rain than we normally have. So what happens is that the trade winds increase. And so the cold water over here in normal conditions will extend further before warming up because the winds are blowing them harder and faster. And so that's what occurs. So the cold water goes further along the equator before warming up. So it's going further west in the Pacific. And so what it normally means for us is drought. Now, it looks like it's the whole United States, but it's not. So we'll say in the U.S. Southwest. So California, Arizona usually get a drought, Nevada, in the southwestern United States. So that would be here, okay? And so that is La Nina. And again, it usually means drought, but in the year of January 2017, it hasn't meant drought. We've actually gotten a lot of rain this year. And that's it for El Nino Notes.